Well, greetings and welcome to part 3 of our Silvertone 1485 video extravaganza. In this episode, we're going to do an electronic overhaul here on the circuit and hopefully get this beast up and running. Step 1, we take this behemoth out of its cabinet and flip it over so we can observe the innards. You'll be glad to know that I have obtained a really nice original output transformer to fill in that empty gap in the chassis, and also 3 original tube shields. I think for step 1 I'm going to remove this hideous microphone input that's been just tacked in here. I'm going to unbolt it, unwire it, and remove it, and then just get one of those little spring-loaded caps to fill the hole. I'm just going to go ahead and install that good used output transformer in this place here where the old burned out one was. I've excavated some of these sort of unusual 100 microfarad at 150 volt electrolytics out of the way so I can gain access to put the nuts here that will hold the transformer in place. You can see from the blackening of the chassis surface that the demise of the original output transformer must have been a rather spectacular event, okay, at least from a smoke standpoint. I also excavated this electrolytic over here so I can gain access to the plate pins on the other 2 6L6 tubes. Here the existing transformer that's in place is for these 2 6L6s. The one I'm going to install is for these 2. The output transformer is installed and wired. The secondary comes over here to the second speaker array of 3 different 10-inch speakers. And the primary is connected here to the plates of the 6L6s, and the red wire I have not yet connected, but it will be connected, of course, to the B+. Next, I'm going to disconnect the old 2-wire power cord from the auxiliary receptacle and remove it and replace it with a 3-wire power cord that grounds the chassis. Just for fun, I thought I'd check the 3 amp fuse, and it seemed like it was a little huskier than a 3 amp fuse should be, and that's because it's a 20 amp fuse. So you know that a real electronics whiz has been working on this at some time in the past. Okay, so this one goes in the drawer, and I'm going to install a 3 amp as soon as possible. Well, it looks like Jack insists on helping with the video. He's a little jealous over all the attention that Casey's been getting. So here he is. He's joined us. Get that belly. Get that fat belly. Okay, Jack, you going to help? Now that both output transformers are in place, it's time to install a 3-way speaker jack. I really didn't like the way that Silvertone hardwired the speakers to the cabinet because they can really never be separated without unsoldering some connections. So what I'm going to do is use a stereo plug like this. This will be the common connection to this array of 3 speakers in parallel and to this array of 3 speakers in parallel. The hot wire for the top group of 3 will be connected by this segment right here, and the bottom hot wire is going to be connected by the tip. Then the jack here, the plug recipient will be wired to match so that we can disconnect our head from our speaker cabinet. And I will install that 3-way jack in the hole where the grommet was for the 3 wires that originally went to the speaker. So it's in a familiar place, it's just using a completely different method of connection. Okay, here's that 3-way jack installed. You see the red over here, the 2.7 from the right-hand output transformer is connected to this contact. The 2.7 output from the left output transformer is connected to this contact down here, and the common for both is connected to the central part, which is the shield part of the jack. I also got a right angle three-way plug, so the speaker wire could go straight down to the speaker cabinet. Let's check for clearance, and I don't see any problems at all. You do need to check because these contacts will move back when the jack's in place, and sometimes they will short, so you really have to watch that. Okay, in this case, no problem. Now it's time to change out these 4 large electrolytic caps. They're 100 microfarad at 150 volts. I got the closest thing I could, which is 100 microfarad at 160 volts. So let's remove these big rascals and put in these smaller rascals. Alright, now all 5 of these big bulky electrolytics have been replaced with actually higher value voltage wise new capacitors, and notice how uncluttered the circuit looks now. One more kind of oddball capacitor to replace is this 0.5 microfarad at 200 volt waxy cap, and I have a NOS Aerovox 0.5 at 200 to put in its place. Now that all the capacitors on the left side of the amp have been replaced, it's time to replace the 2 cathode bypass caps and the 3 high voltage filter caps that are in this can. It looks like Jack's not the only one who enjoys a little catnip once in a while. Casey, what do you think? Oh yeah, we love that catnip. I removed all of the leads from the original filter can capacitor and installed 3 brand new electrolytics in its place, as well as the 2 resistors that were present in the power supply. Now as we look over the circuit, it's much less cluttered and completely rewired with expendable components replaced. I've got to tell you that it was not easy to do, especially this part right here, and I really wouldn't recommend this for a first-time capacitor job for anybody. I think it would be better left to somebody that had had some experience. Okay, so you're forewarned. Now, using one of those compression grommets, I have installed a 3-wire power cord with the green wire securely grounded under a nut to the chassis. Now it's time to recon those 3 bad speakers. I've posted a video that goes into great detail on how to do this. I'll just cover a couple of the points for this video. Number 1, I disassembled the first speaker. You remove the old speaker cone, and if you can, remove the spider and the voice coil and dust cover all in one piece. This can be used again. If you have a speaker that has a perfectly good cone but a burned voice coil, this can save it. Also save your old gaskets. They can come in handy for future repairs. In this particular case, I've ordered a kit that has all the parts I need to restore this speaker. Now that it's apart, you can take advantage of that fact and clean the inside very carefully. You can even repaint it if you wish. This one cleaned up pretty well, and be sure that this rim here is clean of rust and glue. After you've removed the old spider and voice coil and dust cap, it's a good idea to cover that gap between the magnet and the body of the speaker so that extra dirt doesn't get in there while you're cleaning the basket. Okay, once you're done with all the cleaning and blowing it all out with compressed air, then we're going to remove the tape and get started on fitting the new voice coil. And the best way to clean this gap that I've seen is after spraying with compressed air. wrapped some masking tape around a piece of fairly stiff cardboard and with the sticky side out, and then push it down in there and go all the way around so that any dirt, dust, or metal particles will stick to the tape. Now you'll have a really nice clean space. Then, using the color-coded shims and the specific directions provided in my reconing video, I've positioned the new voice coil vertically so that the top of the coil winding is just visible above the edge here of the speaker basket. And the two little hair-like wires are pointing over here to where they will connect ultimately to the speaker basket through these two eyelets. Then we apply a thin layer of yellow super weather strip and gasket adhesive to the perimeter of the bottom of the web of the spider, and using the shimmed voice coil as a centering guide, we drop it down so that the contact cement will make it permanently adhere to the speaker basket. Make sure that there is no pressure against the voice coil anywhere. Now mix up a batch of 5-minute epoxy and apply a bead between the spider and the voice coil, fairly uniform all the way around. Then, while the epoxy is still soft and sticky, drop the speaker cone down and let the epoxy that's on the spider seep up through and glue the cone to the voice coil in a very neat and uniform fashion. Well, I've finished reconing 2 of the speakers that were so badly damaged. This is the one that had all the rat chewing along the bottom and was at the bottom right with a big hole in the grill cloth that allowed you to see just what a mess it was. As you can see now, the cones are virtually identical to the original, and the dust covers are too. So these jewels have new voice coils, everything, and they're ready to be installed. Every time I hoist this behemoth up onto the workbench, I'm reminded of why I generally prefer single-ended compact amplifiers. This thing, with the 3 additional speakers I'm about to install, is going to really be a handful. Okay, I've unscrewed the 89 screws that hold the back in place, and now it's time to lift it out of the way so we can install the speakers and get them all wired up to our stereo 1/4-inch jack that's going to fit into the back of the amplifier. Okay, all 6 speakers are safely ensconced in their cabinet, and now it's time to wire them. Now, as I've told you before, polarity does not matter when you're wiring speakers if there's only one speaker, because there's nothing for it to be in phase with. But when you have multiple speakers like this, they have to be in phase to sound right. So to be sure that that happens, I'm going to mark the corresponding terminal, in this case the left one, on each speaker with green dye. Now once we become the mirror image over here, now it's going to look like it's the right terminal that's going to be marked, but it is the same corresponding terminal on all 6 speakers. Now these 3 will all be wired in an array and in parallel. These 3 will be a separate parallel array. Let's get started wiring, and I think it will become clearer. For wiring today, I'm going to use my brand new Weller model 8200 solder gun that was sent to me by a viewer named Patrick. A very generous Christmas gift, and I truly appreciate it. It's going to get lots of good use. Thanks, Pat. Okay, I've wired all of the hot leads on the speakers, and instead of just having wire hanging here in festoons, I'm running it down to the baffle surface and through a little wire holder here to keep it out of harm's way. I did the upper array, as you can see, in blue, and I brought it over here to a 3-terminal screw-in jumper strip, and the common lead that's going to go to this terminal on all of the speakers will come over here to the central position. Now the beauty of this setup is I'm going to now, once I finish this, wire a cord for the amp that will just reach far enough up to plug into the back of the amplifier head. And it will screw in these 3 positions right here. Now if you wanted to use a longer cord, you can simply unscrew the short one and screw in the longer cord that you pre-made for that purpose. Okay, so I really think one of the main components of good engineering is just thinking ahead, and this would give versatility, and I think it looks nice. Okay, there's the speaker wiring finished. You can see that each speaker has a red or blue and a black lead. They're all in phase, and they're over here at the terminal strip waiting for the cable that will connect them to the amp. I think it's a real good idea to keep these wires out of the way, because when you're pulling your amp head out from the bottom of the cabinet and you snag the wires and disappoint the crowd at Shea Stadium, okay? And that's just not professional. So I think this is a better way to do it than they did, and I hope you agree. Alright, now the cable that will run up to the amp head has been wired into place. The green wire for neutral and blue and brown for the 2 separate speaker arrays. I've then run it into this 3-way plug. The neutral will be this body right here, and then this will be one array and the tip will be another. So when it plugs into the amp, then the speakers will be connected as they should be with about 2.67 ohms of impedance per triple array. And I've cut out some nice foam pieces here to cushion the amp head cabinet when it is slid into place. I'll put it into place now and we'll see how it fits. Several viewers seem very concerned that the amp head would no longer fit into the bottom rear of the speaker cabinet because of the thicker speaker baffle that I used. But as you can see, due to these more compressible foam blocks, the head does fit down so that the little retainer arms here can hold it in quite well, and it is actually recessed down below the lip of the speaker cabinet, so with the knobs down in here it should be completely out of harm's way. I think it fits just about the same now as it would have before with the Masonite baffle. Well, now it's time to say goodbye to that upper array of 3 Jensen speakers as we lower the upper back door into place and screw it back in. Having a chance to closely examine one of these piezo transducers, I've revised my opinion of the purpose of this silvery nut. It is just a silvery nut. Okay, the actual crystal is sandwiched between 2 metal layers in the vertical arm that reaches up between the copper spring and that silvery nut. I believe that the crystal is like this, in between, sort of like a sandwich between the 2 metal plates, and as the spring wiggles the crystal, it generates positive output on one end, negative in the other. Now God only knows which is which, but as you can see, the wiggling up here will produce a potential between those 2 wires. And that is what the signal output is from the transducer. So the crystal is actually sandwiched in here in that vertical arm, not anything to do over here with the nut. This is also why you have paper insulation on this vertical copper support, and also on the little piezo crystal arm itself, Otherwise, you would have a short circuit through the spring. Since the Silvertone reverb tank is a piezo-based device, it should be able to generate electricity at both ends when you wiggle the spring. Now I've hooked up the probe to my oscilloscope to the right-hand transducer, and I'm going to bounce the spring a little bit, and as you can see, there's a good strong signal being output. Okay, now let's try it on the left transducer. Okay, we're connected here to the left-hand transducer. Let's watch the scope as I bounce the spring. We get nowhere near the same intensity of output. Now that either means that the tank is designed to have an input and output end, or this transducer is faulty. The only way to really tell is to test another tank to see if it behaves exactly the same. Fortunately, I have access to several more Silvertone reverb tanks. This one's mounted in the chassis. I'm going to connect just like it did to the first tank, and let's watch what happens when I jostle the spring. Okay, pretty nice output. Now let's check the other end of the tank. Here I'm connected to the other transducer. This is our scope image. Now I'll jostle, and it looks to me like we're getting a pretty good signal out of both ends. So that first tank may be faulty. Now as a quick test on this transducer at this end of the tank, you see our line, and I bang the tank around and nothing. So let's take a look at this transducer here on this end, which has no output, and see why. Right off the bat, it's obvious this tank has been worked on, because that duct tape wrapping that's original has been replaced with Scotch tape, and this arrow pointing at the bad end is sort of ominous. Okay, so let's take a look inside and see. I should point out for clarity that this is not the 1485, obviously. Since I started working on it, I've received two 1484s for repairs. So I'm using them in some cases to demonstrate characteristics of this type of amplifier and reverb tank. And here's what we find. The spring is not properly installed at either end. And also, and this answers a question I had, why are there, on all of these tanks, there's two little cuts made on either side right at the center? It appears that there is a piece of thread that holds the tank spring down at the center to stabilize it. And I'm guessing the signal then will come through here, but the spring itself will be held tight here so that it can't thrash around excessively. This is the only one I've seen that's like this. Of three of these, or four that I've seen so far, but I don't know if that's for transport or if that is supposed to remain with the thread intact while the tank is in operation. I guess we'll have to do some experiments to figure it out. Also, you can see they tried to replace the paper at insulation with Scotch tape at either end without much luck. Let's try to assemble this properly and see if we can get it to work. Now with the spring properly positioned and left tied down, let's check the right-hand transducer. Nice signal. Now the left hand. And the left hand still doesn't work. So I'll disassemble this and check it a little closer. These are my conclusions from experimentation with 4 different tanks. Number 1, the little piezo crystal arm can become damaged over time. I assume it gets cracks in that crystal and it ceases to be able to output electricity or wiggle when electricity is input to it. There is no practical way to repair one, so your best bet then is to get a parts tank and maybe transplant the little piezo crystal from that parts tank to your amp tank, or maybe just find another reverb tank and use it in its entirety. Number 2, at all times the spring must be held down in the middle with thread so that it is very close to but not quite touching the masonite board. This stabilizes the spring so that during transport it doesn't thrash around and disconnect from the end or from the little transducer arm. Also, I feel certain that that sort of moderates extra like reverb noise and extraneous sounds that you might get from the tank. Number 3, reverb problems may not be the tank's fault. You should test the tank to make sure that both transducers are functional, and if they are, then look elsewhere for the source of the problem. It could be a short in the shielded cables, a short maybe in the foot switch jack, or the on-off switch for the reverb itself. So eliminate the tank first and then look elsewhere for the source of the problems. Now, for those who don't have an oscilloscope to test the tank, I found an alternate method using just a simple digital multimeter. Apply your probes to the 2 wires from one of the transducers and then measure its capacitance. I've found that in every case, if you have good measurable capacitance, it'll be rather low. In this case, it's 2.27 nanofarads. But if you have low but measurable capacitance at both ends of the tank is fine. In the tanks that I've measured, the capacitances range from like 1.5 nanofarads up to like 5 or 6. Now I'm going to assume the higher the value, probably the better the transducer. But regardless, they will still work if they have measurable capacitance. Every once in a while, a viewer surprises me with a package, in this case from Paris, France of all places, and look at all of the fine amplifier components. Pots, high-grade capacitors, a really nice transformer set, all types of wire, corner protectors, NOS tubes, bases, shields, knobs, and then the shrink tubing and terminal sets. So I cannot say thanks enough, John. Jack and Casey and I really appreciate this, and we will put it to good use. In fact, here comes Jack right now to help me pick out some items for immediate use. Right, Jackie? And I guess I should have mentioned that John also sent some really neat toys for both Jack and Casey. That's probably what he's up here looking for. So thanks so much, John. We really appreciate it. I'm trying to figure out what's wrong with the reverb, and after tracing the circuit, I found that this switch that's piggyback on the reverb intensity, it's supposed to turn the reverb on and off. Well, you decide how well that switch is working. You hear the click. Switch is not working at all. So I'm going to have to remove all the wires and remove the switch, open it up and see if I can fix it so that it does make contact. Okay, here's that pesky switch and pot combo. I'm going to have to take apart the pot to get to the little tabs that are holding the switch on the back. Now that the rear of the pot's been removed, you can see those 3 little tabs that are holding the switch on the back of the pot housing. I'll have to unbend them and remove the switch to see what's wrong with it. Okay, here's the inside of the switch. There was a bunch of solder residue and dirt that kept it from traveling its full distance. Now watch over here at the ohm meter as I flip the switch, and we see that now it works perfectly. I'm going to have to reassemble it all now and reinstall. Now, after making sure that the resistive track and the wiper and the inside of the little housing are immaculate, we'll reassemble our pot switch and reinstall it. Okay, so here's our nice clean switch, all installed with a nice clean pot. We test to see that, of course, the reverb's going to work. Now that the switch works, nope, not even close. So we got to keep looking for the problem. I was determined to fix the reverb. Okay, everybody says it can't be done, so naturally I had to try to do it. So I traced every bit of the circuit all the way through the shielded cables to that switch that I have already repaired, and I found that there was an inadvertent ground here in the foot switch jack. Once I eliminated the ground of the signal here, when you turn on the reverb and tap the tank, listen to what you get. Pretty darn cavernous. Well, it came time to bias the mighty 1485, and when I discuss what I found, I think you better be sitting down, okay, because you're not going to believe this. First, I mapped out the 4 6L6s, and then their respective half winding of their output transformer, different one for each pair of tubes. And say, for example, this half winding is 87.1 ohms of DC resistance. And then I measured the voltage drop across it while the amp was operating, 0.45 volts. Now that seemed very low to me. Well, no kidding. When you do the math, you end up with about 5 milliamps of plate current. Now, match that with 538 plate volts, and you have a plate dissipation of only 2.8 watts. So there's something seriously wrong here. This plate voltage is outrageously high. The plate current is ridiculously low, and yet the amp works, and it doesn't sound all that bad, but I think it can sound a whole lot better. So let's check into this, okay, and see why the plate dissipation is so low on this. Okay, first off, it seems like our plate voltage is just ridiculously high, well over 500 volts. Okay, we can't tolerate that, and I think the reason is because of the unusual power supply here. There are 3 voltage doublers in this power supply. Now imagine that your wall voltage is 10 volts higher than it was back when the amp was made. 10 doubled is 20, 20 doubled is 40, 40 doubled is 80. So you could have as much as 80 volts over on your plate voltage as a result of 10 volts over on the wall receptacle. I did some calculations and came up with a 250 ohm resistor. Now 25 watts is overkill, but I think it's better to go over than under. So I've installed a 250 ohm voltage dropper between the output here from the voltage doubler network and the output over here that's going to go to the tube plates. Okay, now this should reduce the plate voltage from well over 500 down to about 440 or so, 430, something like that. The second issue was the atrociously low plate current. I've checked all of the connections, everything else, and all I can come up with is that the negative DC bias voltage being applied to the grids of these tubes is just way too high. Okay, so I have installed a adjustable bias pot. Now what this is going to do is, right here is the output of the negative DC bias voltage. I'm running it through the pot and either sending it through these two 330K resistors to the tube grids or to ground through a 10K resistor. Here's a schematic of what I've done. Here are those black capacitors from the bias voltage supply to the right leg of a 50K linear pot. To the center we're going to send the negative DC voltage to the L6L6 grids, and then to the right we'll give it an other option, and that is to go through a 10K resistor to ground. You have to have a resistor here. You can't go straight to ground, because if you turn the pot all the way over so there was no resistance to ground, you would be shorting out your DC bias supply and probably damaging that winding in your power transformer. So depending on this adjustment here, we can raise or lower the negative DC bias voltage that we apply to the 6L6 grids. Okay, let's see if the modifications to the power supply have worked. I've got the amp plugged in, turned on, and the variac all the way wide open so that we're at a wall voltage level. We look over here and the plate voltage now is not, what, 535, it's 445, which is about right for 6L6 GCs. Now let's check the bias on our output tubes. Now by turning the adjustable bias pot, I can control the voltage drop across the 82.2 ohm output transformer winding. And as you can see, I can crank it way up and I can crank it way down. My calculations tell me that around 2.6 is going to give me a decent bias on this tube. Let's see. Let's go with 2.63. So now let's calculate our plate current. 2.63 voltage drop divided by 82.2 ohms is equal to almost exactly 32 milliamps, which sounds right on the money to me for 6L6 GCs. I know that's very conservative, but that's the way I want to keep it on this old amp. Now let's calculate the plate dissipation. The plate current in amps times, what was it, 440. Plate voltage is going to equal 14 watts of plate dissipation, which sounds acceptable to me. 1484 and 1485 Silvertone amps have somewhat of a reputation for humming, and much of the blame is placed upon the positioning of the very large power transformer right in the center of the chassis, so it creates an electromagnetic field that really plays havoc with the signal. Now, two things you can do to reduce the hum down to virtually none is to change the input jacks on channel 2, which are located right here with the power transformer, to the self-grounding type, so that when they're not in use, the contact tip is grounded. And then secondly, the foot switch for the tremolo and reverb is like a giant antenna here for hum. So I enclosed it in a grounded sheet metal box, and between these two steps I've virtually eliminated any hum from the amp. Well, here's the moment we've all been waiting for, the final unveiling. As you can see, as Jack runs by in the background, the amp head is all finished and back in its cabinet, connected to the speakers by that relatively short stereo plug. Few stains on top. I left the cabinet with the original Tolex covering. That may change in the future, but for now I just thought it best to keep it original. And now it's time to strum a few chords through and test all of the different controls on the amp. Okay, we're plugged in, the amp is on, and as you can hear, it's nice and quiet, especially for a 1485. We've got the volume at a little less than 1/4, and both the treble and bass are straight up. Well, as you'd expect from 6 speakers, the bass and mid-range are extraordinary. The treble I cranked up just a tiny bit to clear it up. Okay, so that's channel 1. Now let's try channel 2 with all the same settings. Sounds about the same as channel 1 to me. Now let's try the tremolo. Okay, I'm still on channel 2. The tremolo now is both controls are straight up, like 5 out of 10. That's for speed and depth. I think all you tremolo hounds out there in YouTube land will have to agree that sounded pretty sweet. Now let's try the tremolo just WFO, okay, both intensity and speed. Now let's try that infamous reverb. Now I've heard tales that the reverb is weak, but as we'll see, that's not the case. If anything, it's too strong. Okay, I'm right at about 1/4 reverb right now. See what you think. Really good sustain on the reverb, and to me about 1/4 is about all you need, but let's crank it up and see. I think you're going to find at much higher settings it really is overpowering. Well, I have to say the 1485 reverb at half setting sounds like 13 on most other reverbs. Now I almost hate to do it, but let's crank it all the way up and see what happens. Good grief, that probably registered on the Caltech seismograph. But so much for weak reverb rumors, at least with this amp head. It sounds to me like just over 1/4 reverb is about where it belongs. Now for the grand finale, let's try a little combo platter here of a little over 1/4 reverb and 50-50 on the tremolo. Okay, now it's time to turn the mighty 1485 over to the tender mercies of Ollie and Jack to play a few hopefully familiar tunes. I hope you enjoy them. that's about it for this lurid expose on the Silvertone 1485 amp. It started out as a foul-smelling rat's nest and ended up being a pretty darn nice amp. I hope you'll agree with my assessment. I wanted to thank all of the people who contributed to this video, both with parts and advice, and also through Patreon pledges and PayPal contributions. You guys keep us on the air, and I just want you to know how much Jack and I appreciate it. So without further ado, let's go take another look at the Chevy 350 engine and see how it's come along over the past few weeks. We're going to jump ahead here a little. I've taken the engine off of the hoist and mounted it on an engine stand, removed the headers and water inlet and other fittings and things like that, and now I am scrubbing and detailing the intake manifold, getting rid of the ugly old rusty bolts and all the grease and dirt, and putting in a new set of bolts and getting it to where it looks not new, but almost like new. I also removed the starter motor and just went to O'Reilly's and bought a brand new one, and I also bought a brand new lifetime warranty water pump to be installed after I paint the block and detail it. I'll probably also have to pull the harmonic balancer so that I can replace that seal that it passes through in the timing cover, and then to properly paint the whole front of the engine. Now that the engine's up on the engine stand, it's a whole lot easier to work on because it's up high and it's reasonably stable, a whole lot more stable than it is hanging from a chain. Now I'm detailing the intake manifold and getting all these ugly old corroded rusty bolts out of here, and then using a wire brush and chemicals to clean up the manifold. It's pretty tricky in these little indented areas, but as you can see, it can be done, and I've already done it over here on this side, and I have replaced the ugly original Good Wrench valve covers with a super nice tall finned aluminum valve cover. You can see I've already detailed back here. I've got the longer studs. I'm going to use a 1-inch phenolic spacer here to get the carburetor up off the aluminum manifold to prevent overheating of the fuel bowl in the summer. I'm a real believer in these phenolic insulators, especially out here in the Southwest where it'll be 110 or 15 degrees in the summer. So the carb is going to sit right up here on top. Also, you see I have a new oil spout, breather, and water filler neck that I've installed, replacing that hideous old rusty cast iron one that was in place. I'm going to go with no breathers at all in these finned tall aluminum valve covers, relying on this to be the ventilation for the crankcase. It's just a lot easier. You don't have oil drooling out all over your nice aluminum, and it also looks really old-fashioned. This is the way the engines were in the old days. Might not be optimum as far as emission standards, but it sure does look good and seems to work fine. I've also scrubbed and painted with a semi-gloss engine paint the timing cover and front part of the engine and harmonic balancer. I removed and polished up the little timing mark unit, and also have painted this side of the engine. I removed the thermostat and cleaned it up and then put it back in after the block was painted. Oil pan's painted, and there's that new oil filter. You remember the trouble I had with the old one. And then a new dipstick, tube, and stick. The rear of the block is nicely detailed. Most of these Good Wrench blocks were cast in Mexico, and they're supposed to be fairly soft alloy. This one though is made in Flint, Michigan. It's an all-American block and probably should serve us quite well. Now I finished painting the passenger side of the engine, installed a new fuel pump and the finned aluminum valve cover on the passenger side. I got a new chrome hold down for the distributor. Got the phenolic block in position with the studs properly installed in the intake manifold. These are extended, of course, to compensate for the thickness of the phenolic block. So we're looking pretty good. I think we need a water pump and a starter. Now I bought brand new parts, a new starter and a new water pump, both with lifetime warranties. So after I've installed them, this thing should be just about ready to start. Oh, and of course the exhaust manifolds, or headers, will have to be put in place. Looks a little better than it did when I brought it home.